Hey folks, well, let's see. Last time around we were looking at basic loops, for loops, while loops, do while loops, some of the things with local scopes for our loops. And what I want to do now is to introduce a couple of more advanced control structures for loops, ways that we can get out of loops early or that we can skip parts of loops, and the idea of nested loops, putting loops inside other loops and looking at the behavior that we get then. So those are the couple of things I want to get through today. Maybe we'll take a little bit of time afterwards to look at just some good style ideas for when you're actually writing your loops, the use of indentation to make it visually clearer where loops begin and end. And we'll take a look at a couple of the common errors that we all run into when we're working with loops. So that's the idea. We'll start off with break and continue. So this first extra control mechanism is called break, and it gives us a way to leave a loop early. So usually the idea is, we have some special condition we want to check in the middle of the loop and say, if this condition is true, then I want to leave right now. Don't finish the loop, don't go back and test the top condition again, just leave right now. So it's just a way to leave the loop early, and it's just the word break and a semicolon. So usually we'll put this inside an if statement, we'll check a condition. If the condition is true, break. So, and again, what it does is takes us out of the loop that we're in right now and goes to the sort of first instruction after the end of the loop. It is generally avoided, at least to a degree, in terms of style or habits. And the idea is that when you're adding these breaks into your loop, you're creating multiple different ways you can get out of the loop. So ordinarily, if somebody's reading your code or modifying your code, they look at that loop test condition, and that's what tells you if you're going to get out of the loop or not. If you've got break statements scattered through the body of your loop, then they also have to go through and say, okay, well, here's the main way to get out of the loop, but I have to go digging and see if there are other ways to also get out of the loop someplace else. And so it does tend to just obscure a bit the functionality, the control of the loop itself. And so it is at least somewhat preferred to have the loop control logic obvious, right at the top or right at the bottom, as opposed to having pieces of it hidden inside. But you'll certainly see break used a fair bit, and there are times when it makes sense to use a break instead of to kind of complicate the overall loop control structure. If you've got something that's a really unusual circumstance that could reasonably be expected to end the loop action early. But we'll look at the syntax for this because, again, this is something that you're going to see. So as an example, what we'll do here is get the user to enter 10 values, and we'll add them all together and print the sum at the end. But we'll add in this extra break that says, if the user enters a 0 somewhere in there, we'll quit early, right? We'll quit as soon as they enter the 0. So they can enter any other values that they like, and we'll add them all up. But if they enter a 0, we'll quit and just tell them what they've added so far, or what they've given so far. So what we'll do is have our count for the number of values that we're adding up. So we'll say we're going to add up 10 numbers. Our sum starts at 0, our total starts at 0. And while the number of values we've added together is still, or is the number of values we have left to add together is still greater than 0, we'll get the user to enter another one and add it to the total. Right? So we'll enter an integer, we'll read it in, ignore the if statement for a second, we'll add it to the running total, and we'll drop down, now we've got 9 left to go. Get another value, and then we'll have 8 left to go. Get another value, and then we'll have 7 left to go. But we'll throw in this extra idea that if the value they typed in happened to be a 0, then we'll treat that as a sign that they want to quit right now. So maybe I should probably change my enter an int or 0 to quit as a better prompt for the user. So if x is 0, then we'll say that's the time to leave, and so we just throw in that word break and the semicolon. And again, what that says is, okay, well, if x was 0, then let's leave right now. We won't do the addition, we won't subtract 1 from n, we won't go back and test again. We'll just jump straight out of the loop and go on with the rest of the program. That's in this case just printing out the sum. So it is certainly an option in terms of adding an extra way to get out of the body of a loop. So continue is another one of these sort of added control capabilities, but in this case, instead of leaving the loop, it says, I just want to skip what's left in the body of the loop and go to the next condition check. So if it's top tested loop, then we'll jump up to the top of the loop again and do our test and continue on normally from there. It's just saying for this pass through the body of the loop, let's skip the stuff that's below the continue. So it gives you a way of just skipping part of the loop. So similar style in terms of how you use it. You'll have some condition and say, well, if this condition, continue. And then otherwise it goes on with the body of the loop. It does have similar concerns in terms of obscuring the loop functionality. Perhaps a little bit less so, since we're really just skipping part of the content of the body. We're still not using it to get out. We're just using it as a way to bypass part of the control on, or part of the actions on this one pass. So again, you are certainly going to see continue in code that you look at. So just to do another example, this time we'll again get the user to enter 10 values. We'll add them all up, but we'll only count the values that are greater than or equal to 0. So if they enter a negative number, we won't count that as one of the 10s. We'll just continue going on. So again, we're going to have n as sort of our count of how many values we've got left to get. And each time we get a value from them, we'll drop it down by 1 and we'll add the value to the running total. But, usual idea, we'll prompt them, read it in. If they enter a negative number, then we won't count that as one of the attempts, so we won't decrement n, and we won't add it to the running total. So if they enter a negative number, then just jump straight back up to the top and see if we've got all 10 values yet, and continue on. So it's just a way of bypassing, if you like, the bottom half of the loop. In this case, we're saying if they gave a negative number, then don't add it to the total, don't decrement n, just go back up to the top and continue on from there. So again, there are times when this might be a reasonable way to handle things. An alternative would have been to say, okay, well, if x is greater than or equal to 0, then do this sum equals sum plus x, n minus minus. So there are always alternatives to writing your logic, but again, you'll certainly see continue used in different examples. All right, it wasn't too much I really wanted to go into more in terms of break and continue, but I did want to get into talking about nested loops, putting one loop inside another loop. Now, to do this, the inside loop, the inner loop, has to be completely inside the body of the outer loop. So you can't have sort of loop 1 begin, and then loop 2 begin, and then loop 1 end, and then loop 2 end, right? The inside loop has to be completely inside the enclosing loop, the outer loop. And what happens is that each time you make one pass through the outer loop, the inner loop runs all the way to completion. So if the inner loop runs 5 times, so if you've got a for loop that runs 5 times, then it's going to run those 5 times each time you go through the outside loop. So probably the clearest way to show this is with a bit of an example. Let's have a program where we want to print 5 lines of output, so we'll have a loop to control going through the 5 lines. And on each line, we want it to print out values 1 to 10. So we'll have another loop that controls printing out those 10 values. Now, here we're saying we want 5 lines, and on each of those lines we want the 10 values. So that means our outer loop should probably control the number of lines, kind of which line we're on currently, and the inside loop is saying, okay, well, while we're on this line, we need to print these 10 values. Right, so we'll have our outside loop controlling the 5 lines, and the inside loop controlling the 10 values for the current line. And so in terms of syntax, we've got our outside loop here, right? Just ignore what's in the body for the moment. Our outside loop is saying for line number 1 through 5. So again, we're starting, if line is keeping count of which line number we're on right now. We'll start it off at 1. We'll keep going while it's less than or equal to 5, and each time we'll bump it up by 1. So the first time it's line 1, second time it's line 2, third time it's line 3, etc. So we've got that outer loop that kind of contains everything, and it's going to go through 5 times. And then on the inside, what we'll do is print out the current line number, and then we'll print out the 10 values. So, and then print out an end of line. So we've got our printing out, the current line is, and at the end of it, we'll print out a new line to go to the start of, line 2 or line 3 or line 4, whatever it happens to be. And then we'll have this inner loop that says, okay, while I'm working on the current line, I want to go through and print the 10 values. So I'll have n keeping track of which value I'm on right now. Right? So we'll start n off at 1, and while n's less than or equal to 10, we'll print n and then add 1 to it. So again, this is going through and saying for when the outside loop is on line 1, we go through and print line 1, and we go through this loop 10 times, printing out the 10 values to go on line 1. Right? We'll print out the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we'll print out an end of line. Right? Eventually this inside loop ends, we print out the end of line, and then we can go back and make our second pass through make our pass for the second line. Right? So now we're on line 2, and we go through this whole thing all over again, but for line 2. So we print out line 2, and then we go through this loop, this time printing out the 10 values currently for line 2. Right? So we print out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for the inside line, or for the second line. And then again, once we're done here, we print out the end of line at the end of line 2, and we go back, and we're on our kind of third pass through the outside loop, going for line 3. Right? We print out line 3, and then we go through this loop 10 times, printing out the 10 values that belong on line 3. And so you get this kind of a structure where the outside loop is controlling, how often you do the big action, if you like, and the inside loop is controlling how often you do the little action. Right? The big action being a line, and the little action being one of the values on that line. So this is, again, a structure that you're going to wind up needing to use. Quite often we've got some bigger action that we have to repeat a bunch of times, and then some smaller action that we have to do a whole bunch of times during the bigger action. Say you've got a program that's going to let 2 players play 10 games of tic-tac-toe. So during each game, there's going to be a whole bunch of turns. So you might have the big outside loop that controls how many games you play, and then that inside loop controlling how many turns you play in that current game. And so again, for each game, you're playing all of the turns in that game, and then you move on to the next game, play all of the turns inside that game. And so you've got the kind of outer loop controlling the bigger thing, and the inner loop controlling the smaller actions within the big one. Let's see, let's play with maybe one more example just to show something other than the for loops with this. So let's try a nested loop example, maybe using while loops. Can't type. Let's see, maybe this time around we'll let's get 10 numbers from the user and add them all up. But when getting each number, get them to try again until they really do give you a number. So let's have our total is 0, and let's say our value count is 0 so far, and let's say the number of values needed is 10. So what I'm going to do is say essentially while I don't have 10 values yet, while my value count is less than the number of values I want, I'm going to get the next value from the user and add it to the total and bump up my count of the total number of values. So we'll get the next value from the user, and then we'll adjust our value, adjust the sum and the value count. Right, so our total is equal to the total plus the current value, and I haven't declared current value yet, but we'll do that. And our value count goes up by 1. So let's have a variable for my current value. So this is going to be the one that the user enters. Now, here is where we want our inside loop. So here is where I want to here's where I want to keep getting new values from the user until they actually give me a number, right? So maybe they type in foo, they type in blah, they type in junk, and then finally they type in an actual number. So here I'll get the user to keep trying until they give me a number. So this is going to be another loop. Now I'm going to use a do while loop this time. So we've got a do while loop inside our while loop. So I'm going to have a variable. So this is where we'll throw in another one of our Boolean variables. Let's say the value bad. So I'll set this to true if bad entry, false if good entry is the idea. So I want to keep going while they've given me garbage data. So inside the loop, I'm going to have to prompt them, attempt to read in what they entered, and then decide if it was good or bad. So my inside loop is going to say, enter a number. We'll read it in, or at least we'll try to read it in. And we want to put it in our current value. And then we want to see if this failed or not. So if cin failed, then it's a bad value. Now I can tell them that was not a number. Try again. And I'll flush my input buffer because cin couldn't read the garbage that they typed in. So I'll do my cin.clear to get rid of the error flag, and my cin.ignore to get rid of the garbage. Right, so that's our handling for if they entered garbage. Otherwise, anything else, as long as it wasn't garbage, it's a valid number as far as we're concerned. So otherwise, my value bad equals false. Right, the data is okay. So this is kind of one of our typical loops, and if you ignore the outside loop for a moment and just focus on the fact that here, right now, all we're interested in doing is getting a valid number from the user. So we've got this little inside loop that's just saying, okay, go through as often as you need to get a valid number from the user. Right? And so this is just going through again and again and again. Eventually they give us a valid number, and we can go on and add it to the running total and bump up our count of how many things we've managed to read in so far. And then again, for each successive one of our 10 numbers, right, we're going through this process 10 times. 10 times we're going through the process of getting a number from the user and adding it to our running total. And each of those 10 times, we might have to make multiple tries to get the user to give a valid number this time around. And so that's the notion of having our sort of nested loops, is having that little inside loop that's running multiple times. So let's print out our total at the end, and then we can debug this and find out how many errors I've got in it. Turn on all my various warning flags. Oh, woohoo! And we'll try running nested. So it's entering a number. I should clean up my my output here. That's not very readable. So the first time through, let's actually give them a valid number right on the first try. And so I give them a 7. And it says, okay, that's fine. Well, let's do a run where I just give it valid numbers each time through. Is that 10 numbers? Hopefully. 3, 4, 5, 6, 7, 8, 9, 10. Yeah. And it add them all together. So seems to work okay there. It's not terribly obvious here which pass we're on. So let's tweak this a little bit, and let's enter the, and the grammar's not going to come out quite right, but value count tells us how many things we've read in so far, but it's 0 in the beginning. So I want to get it to say something like enter the first number, enter the second number, enter the third number. But I'm going to be a little bit lazy here and just say, so it'll enter the 1th number, the 2th number, the 3rd number. And maybe I'll throw some white space in at the end of that, just so it's a little bit more readable. So it's going to tell me, when it's prompting me, how far I've gotten through the process of entering my 10 numbers. So let's try compiling that again, and let's try our nested again. And so enter the 1th number, so I'll say 10, 20, 30, 40. And so we do get the desired behavior, and here that inside loop is only running once each time. But, you know, if I run this again and I enter foo as my 1th number, right, I get that inside loop goes through and says, oh, that wasn't a number, try again. And so I'm doing that inside loop again for the first number. Blah. And again, I'm doing the inside loop yet again for that first number. And now I actually enter a number, let's say, you know, enter the 2th number. So let's say I enter a 1.5, that's fine. I enter garbage for the 3rd. And again, we're going through that inside loop, still working on the 3rd number. And again, hopefully things should plow through reasonably nicely. But I get my running total. And again, you've got this notion of this inside loop is running possibly multiple times on the current pass through the outer loop. So that's the kind of process I wanted folks to be aware of when they're looking at nested loops and when they're writing nested loops. Now, in terms of indentation habits, we want it to be visually clear where chunks of code begin and end. And so we can use our indentation to do that. So let's go back and take a look at that example in just one moment here. We've got all of the stuff that's kind of global lined up against the far left-hand side. And then what's inside something else, what's inside the body of a main or what's inside the body of a loop, we indent, say, 4 spaces to the right. And then if we have another loop inside that, or an if statement inside that, we indent it yet another 4 spaces. Right? And that's what I was doing in the code example that we were just looking at. Right here, you can see that the things that are global, the hash include and the using namespace and the int main, and typically we'll line up the brackets with the thing that they're beginning or ending. So I've got my brackets to begin and end the main right on the left-hand side there. And then stuff that's inside the body of the main, the comments, the variable declarations, the code statements, all indented 4 spaces here. Actually, I've been inconsistent because here I've indented 3 spaces. But and then once we start another loop, we indent. I should really make it 4 more spaces. I should be consistent here. Yeah. So, stuff that, oops, I've gone too far here. No, I haven't. Okay. Let's see, so we indent 4 spaces for the loop, and then, or 4 spaces for the main, and then 4 more spaces for inside the body of the loop. Right? And then, if we get another loop inside that, we'll indent 4 more spaces. So everything that's inside the main, right? Everything that's between that opening and closing, or everything that's inside the do while, rather, everything that's between that opening and closing bracket will indent yet another 4 spaces. And then we get an if-else inside that. And so we'll indent everything inside that. 1, 2, 3, 4. Another 4 spaces. And you get this kind of clear visual picture where you can glance at something and see where things begin and end. Right? You can see visually the stuff that's in the do while because it's all indented that much. And you can see stuff that's in the if, the body of the if, because it's all indented that much. It gives you these visual cues as to where things begin and end. And that does save, it's amazing how much brain power it saves when you're trying to scan through code looking for key points that you want to debug. So this is one of those things that I'm going to kind of expect and enforce in terms of code standards, this notion of consistent indentation. But that was the point I wanted to make there. The last thing I wanted to mention was just a comment of the kinds of errors to get used to encountering when you're working with loops. Infinite loops are one where you forget to update the variables in your that you're using in your test condition. So let's say, and we had an example of that a little earlier here, where let's create an infinite loop here. Oops. Let's try actually getting the extension right. So we've got our namespace, and I'm just going to throw this in the main routine for now. Suppose I want to get the user to enter 10 numbers. And again, we will print the sum. So we'll have a double for the sum. We'll have a double for the current number. And we'll have a double for the number of vowels entered so far. And so what we'll say is our sum is 0 to begin with. While the number of values you've entered so far is less than 10, we'll keep going. All right, we'll read in the next number. I'm going to skip the error checking for now and just focus on the infinite loop part of it. We want to add the number to the sum so far. So we get this kind of running total. Maybe we'll print out the total so far. And we'll just leave it. Maybe we can print the final total at the end here. So what I've neglected to do in here is I'm saying, well, the number of values they've entered so far is less than 10. Read in another one, add it to the running total, print the running total so far. I'm forgetting to adjust my number of values entered. Say, oh, they just added one more, right? So I should be adding one to this each time through, right? My number of values goes from 0 to 1 to 2 to 3 to 4 to 5 as we're reading in new values. But I've forgotten to do that, so it'll compile fine. Oops, if I can type my commands correctly. Yep. Ah, there we go. Let's fix some syntax errors here. Missing my less than. Try compiling again. That's more like it. So I enter, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, oops, 10, 11, 12, 13, or, I can keep entering new values. And again, it's just never stopping here because I'm forgetting to keep track of how many values I've actually entered so far. So this is where our Control-C comes in. Control-C kills the current program and gets me back to my command prompt. So infinite loops, not at all uncommon. And again, what I really wanted to do in here was to remember to go, oops, my number of vowels entered so far has just gone up by 1. And so that will make this condition stop after our 10 tries. All right. Let's see. So infinite loops, again, oh my goodness, I just went through all that and didn't show you the code, did I? I've got the window going on my screen and not on your screen. Dear, oh dear, oh dear. Okay, let me back up and I'll show you what that code actually looked like. Goof. Okay, so this was what my code looked like on that first attempt, where we're going through and prompting the user, please enter 10 numbers. Keeping the running total. We'll keep track of how many values they've entered so far. So in the beginning they've entered none, and then we'll change that to 1, 2, 3, 4, etc. as they enter the first one, second one, third one. And we'll quit once they've entered 10 numbers. And so my sum is initially 0. On each pass through my loop, I read in the next number, add it to the running total, print out the running total, and then I should be updating my number of values entered. So it's now 1 or 2 or 3 or 4, and so that eventually it hits 10 and this thing ends. But what I did there in this particular case was I went through and forgot to adjust my number of values entered. So this is our example of an infinite loop. Yep. So again, if we compile this and we run it, then it doesn't matter how many values I enter. It's not keeping track of how many things I'm entering, so it never knows when I've entered 10 of them, and so it just never ever stops. And this is where I used my Control-C to kill it and get out. And again, just to kind of confirm that what we actually wanted was to go through and update that number of vowels entered each time through, so eventually it knows to quit. And so this time, hopefully once we get 10 numbers in, it actually quits and spits out the total. So there's the example of the infinite loop. All right, take 2. So infinite loops are one of the most common forms of errors that we'll deal with in working with loops. Off by 1 errors are another common one. And usually so the idea is we've got a loop that runs through one time too many or one time too few. And usually that's just a simple tweak where we've missed up where we should use a, say, a less than instead of a less than or equal to, or a greater than or equal to instead of a greater than. So in that example that we were just looking at, I wanted to go through and get 10 values from the user. And let's say I was just thinking, okay, well, I want to keep going while I'll start with value 1 and I'll keep going while it's less than 10. And so you go through and you run this, and it's only actually going to read 9 values. And again, this, when you're just kind of mentally typing out your stuff, it's quite common to say, okay, well, I want to go from 1 to 10, so start at 1 while it's less than 10, it should be fine. And we compile it, and we run it. And I got 9 values in, and then it stopped. So this is one of those examples of an off by 1 error where, based on whatever values I initialize my variables with and whatever stopping condition I've got, it just stops one time early, or it goes one time too many. So I could have changed that to well, the number of values entered is less than or equal to 10, do it this way, or we could have used the way we had it originally, was starting at 0 and keep going while it's less than 10. Again, typically it's just a simple tweak, increasing or decreasing one of your initial values by 1, or changing a condition to less than instead of a less than or equal to, or whatever the case might be. All right, so off by 1 errors are also pretty darn common. And then the other one are cases where we've got scoping errors, where, as we mentioned when we were looking at the scopes of variables, if we declare a variable inside a loop, it's only visible inside that loop. And so it's pretty common. Usually you'll get warnings about that when you try and compile, because it'll tell you that you're using a variable that doesn't exist in the scope where you're trying to use it. The other possibility is where you create a variable, say a variable that's local to the function, and then you've got a loop inside the function, and you declare another variable with the same name inside the loop. And so when you're using the variable inside the loop, it's using that inside one, but then once the loop ends, you're going back to using the outside one. And if you forget that you've got these kind of two things with the same name, you can wind up with unexpected behavior. Safest way to avoid that is to not have two variables with the same name whose scope overlap. But again, it's just one to be aware of. Scoping errors are not at all unusual. So those are probably the 3 most common kinds of errors you're going to run into when working with loops. Just something to be aware of. And again, the kind of typical quick fixes. All right, I think we will leave the looping discussion there for now. We're going to be using these in pretty much every program we write from here on out, so we will get lots of practice with these over the next couple of months. All right.